Hi, my name is Michael Allshouse, and I'm going to be presenting ME 4565, Introduction to Computational Fluid Dynamics. This is a syllabus that's posted on our Canvas page, and you'll have access to, but I thought I would review this so we can spend our time starting material as early as Tuesday. So our course will take place on Tuesdays from 11:45 to 1:25 and Thursdays from 2:50 to 4:30, so not the same time of day, in room 201 in the EXP building. You can reach out to me at any point throughout the semester at m.allshouse@northeastern.edu. We're going to have two office hours, Tuesdays from 3:30 to 4:30 in my office, Snell 201, and Wednesdays from 2:30 to 4:30 in West Village F, room number 118. Homeworks will typically be due on Thursdays. Our course webpage, everything is available on Canvas. This is the main page. You probably have access to this. If you don't, please feel free to reach out. Course description. I won't read the thing in full, but I'll give you a brief overview. For this course, we want to emphasize three main areas. The first area is fluid dynamics or fluid mechanics. So all of you have taken some level of fluid mechanics before this course, and we're going to be taking those items or methods or techniques that you learned or leveraged in that class and applying it in a numerical way or evaluating different fluid phenomena that maybe you weren't exposed to in your first fluid mechanics class. The next thing that we're going to be introducing in this course are numerical methods. How do we go about simulating a fluid? How do we go about solving the ODEs and PDEs that are the foundation of the models that represent what is occurring in fluid phenomena? And then finally, we're going to be focusing on coding. We're going to be developing a library over the course of the semester, primarily, well, exclusively for this course. That'll be done in MATLAB. So we're going to be doing a lot of coding in MATLAB, doing a lot of numerical methods. There will be some ANSYS done in conjunction with the MATLAB, where that's not necessarily coding up a solver, but actually using a commercially developed one as well. So who should take this course? Students who have an interest in fluid mechanics, basic coding, but not necessarily a strong background in it. We don't assume a huge amount of MATLAB background. You took some MATLAB or you got some exposure to MATLAB in Cornerstone, and we'll be providing some refreshers along the way, but it does ramp up pretty quickly, and so you want to make sure you're on top of the coding fundamentals as we work through. Prerequisites for the course: an undergrad fluids class, so ME 3475 or BioE 3310. An undergraduate differential equations and linear algebra class, so that'd be Math 2341 or GE 2361. We will be leveraging a lot of what you learned in differential equations and some linear algebra as well. Textbooks. We don't have a textbook for the class. There's no single book that sort of encapsulates everything that we cover in this course. So there are a number of options out there that will hit on particular areas. Some areas in more depth than others. So for instance, the first course in computational fluid dynamics does a really nice job of mixing in that intermediate fluids methods with numerical methods, but doesn't really hit so much on the coding. The numerical methods for engineers and scientists, that's a very much a MATLAB heavy primer book. There are some other books as well which may deal a little bit more with the actual foundations for CFD, but those are going to be a little bit more optional for this kind of class. Grading. The grade breakdown will be equally distributed between quizzes, homework, take-home exams, and a term project. So quizzes, worth 20% of your grade. There's going to be a brief quiz at the beginning of basically every class. And what's this quiz cover? Well, for our course, we present some of the concepts before you get into the class in what are called pre-lecture videos. Those are available on YouTube. They'll be available through Canvas as well. And they're going to give you a taste of the concept that we're going to be discussing the next day. And you're going to be charged with watching that video before class, learning some of the concepts beforehand, and then you're going to be quizzed on it when you start in the class. The nice thing is we then go through the quiz together as a group. Then you can start to see, okay, these are the areas I maybe didn't understand quite right. We can ask questions. And then throughout the rest of the course, we're actually going to do examples where we build on and further cement those concepts to you. Now, it's hard being quizzed on something that you have watched maybe a 10-minute video on and maybe did a small example yourself. So how is this evaluated? Well, first, there are lots of these quizzes. There's basically almost 20 quizzes throughout the semester. So each individual quiz isn't a huge leverage point. The other thing we do is we drop your lowest scores. So we take 20 quizzes, your 5 lowest scores get removed. So if there's a day where you can't watch the pre-lecture video, that's okay. The problem is going to be if that becomes habitual, then eventually that's going to start catching up to you. So we want to stay on top of the material, make sure we watch those pre-lectures before class, and the quizzes themselves are really not too challenging. They won't deviate too much from what was covered in the pre-lecture video itself. Homework. We're going to have 4 homeworks due before the first exam. We'll have 4 homeworks due before the second exam for 8 totals. They will be posted on Canvas, typically on Thursdays before class, and due the following Thursday before class, with the exception of PSETs 4 and 8, the final homeworks before the exam. To make sure we can cover as much material as possible, we're going to extend how long you have those homeworks for and probably make them slightly longer so you can get as much material covered in the homeworks before the exam as possible. So keep an eye out for those 2 in particular, as the dates and times may change slightly. Exams. We have 2 exams in this course. Exam 1 will take place on February 13th and run to February 18th. Exam 2 will take place on April 3rd and run to April 8th. You'll notice that this actually spans a couple days. The reason for this is our exams take place in 2 phases. Phase 1 is an in-class handwritten exam. You'll be given a couple of short questions for you to work through derivations, maybe do a small hand calculation as well, and this will be done in class. Immediately following the in-class portion of the exam, the out-of-class portion of the exam will be posted to Canvas and made available for you to work on over the course of the next few days. Each exam is going to be worth 20% of your overall grade. Obviously, with an out-of-class portion of the exam, there's an expectation that there's no collaboration. Questions may arise. You can certainly reach out to me, and we'll post some of those Q&A on the Canvas page for everyone to sort of get an idea of what questions are being asked and how they're being answered. Finally, we have a term project. So there's no final exam for the class. The exam 2 happens pretty close to the end of the semester anyway. The term project is going to give you an opportunity to leverage, test, sort of work through the ANSYS portion of the class. Exam 1 and 2 really will not have any ANSYS component on them whatsoever. It'll be focused on the numerical methods, the MATLAB, maybe a little bit of the fluid mechanics as well. The term project is your chance to really dig into ANSYS. And we're going to put a slightly different spin on the ANSYS, the term projects that we have done in the past, where we're actually going to be working with the chemical engineering department to try to model some of the systems that they have in their experimental laboratory. We'll be working with them and talking with them a little bit more and provide you more details as the semester goes along. But you can rest assured that you're going to be given an opportunity to model a real-world system in ANSYS, do some convergence studies, do a parameter evaluation, maybe some design analysis. These things will all be woven into the term project. And we'll be submitting project reports or doing a presentation. We haven't finalized exactly how we're going to do that yet, but we'll certainly be giving you those details far in advance. Software. So we're going to be using MATLAB on a daily basis in our class. You should bring a laptop. If you don't have one, there are resources available to you. We're more than happy to help coordinate those conversations to get you access to a laptop. But you probably need to have MATLAB available on your computer for the second lecture. Lecture 1, we probably don't do much MATLAB, if at all. But lecture 2, we'll be doing coding in class in real time. So you want to make sure you're in a position where you can confidently open up MATLAB, and we'll get started together working through some of our first algorithms. ANSYS is a little bit more tricky. It's a more resource-demanding software. We have a number of different options available to you. There is the option that you can download ANSYS locally to your machine and run it there. The other option is that you can access the COE VLab machines, which has ANSYS available there as well. Pluses and minuses. Personal laptop, you may have lower resource availability. It's also going to suck up your laptop's ability to do anything else. So you may have some resource limitations if you run exclusively on a laptop. If you have an Apple or a Mac, you may not be able to open up ANSYS at all. That may be a more complicated process. Pluses and minuses of the VLAB machine. It's going to require an internet connection. And there are sometimes some tricky bits about where do we store or save our data so it doesn't get erased, and there's more limitations on space. We can talk about this a little bit more once the class gets started. Pre-lecture videos. As I mentioned before during our quizzes, there's going to be a pre-lecture video for all of our lectures where we're delivering content, obvious exceptions being the exams. You need to watch these videos. We posted them on Canvas. We'll post them on YouTube. You can watch through them at your own speed. You can pause, restart, rewatch if you want, or watch me at 2x if you think I talk slow enough. These are available to you. In addition to our pre-lecture videos, we have a lot of walkthrough videos for our ANSYS. We've tried a lot of different delivery mechanisms for ANSYS. What we've found is the best way we can deliver the information for ANSYS is to cover it in concept or in theory in class and allow you to work through a walkthrough video click by click with the corresponding videos posted and available on ANSYS or on Canvas itself. Class recordings. Well, I don't really have live access to the course. We won't have sort of a Zoom that you can join and participate directly if you're remote. We will post recordings of the lectures afterwards. So if you're not able to attend in person, you could, in theory, still take the quiz. The times will have to sync up with when the quiz is posted during the class, and then maybe watch the video afterwards if you like. Class attendance sort of goes hand in hand with this. I don't require attendance, but the reality is with the quizzes, it's going to be a lot easier for you if you're there in person. The other thing is, during class, I try my best to not lecture for a huge amount of time, with maybe the exception of lecture 1, and spend a little bit more time doing, a little bit more time having you guys work with your peers as you try to code up these problems, try to discuss the derivations that are being presented in class. Academic integrity. The biggest thing here, again, is that there's no collaboration on the take-home exams. I'm completely fine with you guys working together on the homeworks. Quizzes, again, you'll be taking those in class. That'll be an individual effort. But homeworks, you're more than welcome to work in groups. Obviously, you need to submit your own work for the individual homeworks themselves. Okay, with that, I think we've covered everything in the syllabus that's unique to this particular class. If you have any questions, feel free to reach out. I look forward to meeting you all next week.